Yeah, it's my honor to welcome you here at Hasso Plattner Institute of Digital Engineering. We are, at the same time, we are in the Digital Engineering faculty of the University of Potsdam. It's a relatively new faculty, 5 years old. I'm Jürgen Döllner. I'm a professor of computer science, leading one of the departments of HBI related to analysis, construction, and planning of complex software-based systems. This is the official title. In my daily work, I'm concerned with algorithm engineering, with computational geometry, with information visualization, with software, with information mining, and in particular, software mining. So, a few words about HBI. We offer bachelor studies, master programs, about 1,000 students. We have a really tough selection phase. If you apply here as a student, it's not too easy to become accepted. We focus on software engineering, on everything that is needed to build complex software systems. This is the original idea of Hasso Plattner. And insofar, I would like to quote this title: we are somehow a factory of software engineers. Yeah. So if you are interested more, just talk to me. What can we offer to companies with respect to education and with respect to contact to software engineers at all ranges, bachelor, master, and even we have a number of doctoral students, about 150. So we, as a relatively young faculty, we are also a very, very effective factory of academic people, yeah, of academic education. So that's all what I would like to mention about HBI. If you have any further question, please contact me. Now, I'm supposed to speak a little bit about a more or less introduction topic, yeah? And I can use this microphone, I guess. So, yeah, let's just start with a very simple question: is software engineering engineering? It's a fundamental question, a philosophical question, and we could possibly discuss many days about this issue. In Hasso Plattner Institute, we ask ourselves this question almost every day. How can we come forward? How can we increase the maturity level with respect to the engineering characteristics of software engineering? Engineering is a very old discipline, and it's extremely successful. Yeah, for example, building bridges last year during vacations, I found this bridge, which is was built a long time ago, and it's still working. Yeah, you can pass even with your car. You can use this bridge. So the question is, what about software systems? Do we really expect to have, or what do we really think about their lifetimes? Yeah. Of course, we are able, especially in the last 200 years, engineering has improved at an enormous speed. For example, the Large Hadron Collider in the CERN is maybe one of the masterpieces of mankind. Yeah, how can you build such a big system? Of course, it's a system composed of many material components, which is quite different to a software system. But if software systems would materialize, it would be much similar to such a big thing here. It's also interesting to see that in engineering in general and in software engineering in particular, so the human factor is sometimes very important, because whatever we invent this as humans and for humans. So robots would do a different engineering. Robots would write software in a different way. Still, we are faced by complexity, and I like to take photos whenever blue screens appear in the public space. Yeah, it's always funny. Yeah, if even in the buses in Berlin, you can see sometimes the blue screens inside. Yeah, where normally there would be some information about the route, and you find the blue screen. And the question is, how comes that we still have this phenomenon? So we should be aware of that. This indicates that the engineering maturity level is really not very satisfactory. I don't talk about what you must do if you drive a very new car. It's driven by my personal experience in the last weeks. You have always to think of where can you stop, turn off the engine, do a reset, and start it again, because your information and multimedia system fails. Yes, this was unfortunately my experience in the last couple of weeks, and so I'm always looking for the next parking possibility, because I fear that almost in every moment something could happen. For example, if you want to turn off the heating of the car. Software factories, this is a topic, it will be addressed by Johannes Bonnet. It's a metaphoric word, yeah, and I'm not sure if it's a good metaphor, yeah. Somehow, yes, it gives you the idea of that software has become an industrial product. Of course, factories are different to software factories, and it's a broad discussion whether we can talk about software factories. But in any case, software is eating the world in all sectors. I think we are all aware of this, and software defines almost every product nowadays. Software has an intrinsic complexity simply because there are so many parts that interact that at runtime are tightly related. At compile time, it's sometimes quite structured well, but especially at runtime, things become really tough and hard to understand. So we have different aspects of complexity. It's a problem domain complexity in general. What does the user really want? What should we build and why? And who will be really the user? The domain complexity, the structural complexity, that is the whole system. If you have many systems, maybe some dozens of systems in your IT landscape, the question is how do these systems evolve, and can you restructure their software architecture? By the way, what you see in this image is Graphite, an app which was co-developed here in my group. It was presented by the keynote of Tim Cook 2 years ago as one of the apps having built in the most complex AI engine that processes images. Basically, it transforms any photos in nice, aesthetically pleasant drawings, for example, sketchy drawings or oil paintings. And Apple realized that this is the app from a software engineering point of view that has the highest density of built-in algorithms. So for that reason, they found it so interesting. Qt, a wonderful middleware example, looks like this. This is a software map at the right side. So we try to find ways how we can visualize the status and the structure of software systems. Of course, you have to get used to such a picture. Yeah, it's not immediately understandable, but if you know your system, you can more, like if you know your city, yeah, you can orient yourself inside such a visualization. Just a few facts about Qt. It's a very good test framework if you do research in that field. Behavioral complexity, okay, what happens at runtime? Yeah, sometimes it's based on hope. And everything goes the right way, because the runtime complexity is completely out of scope for humans. Yeah, we have to find here strong methods to visualize the runtime complexity. There's also process complexity because it's about humans. Yeah? How do human developers interact, how to say work, and what goals might they have, and their bosses as well. Yeah? It's a complex psychological issue here, how these processes really work, because it's hard to measure anything. Yeah? You can believe what they tell you, and sometimes they can prove a little bit what they did, but in general it's at least a gray box, sometimes a black box. So the degree of maturity is a good starting point. Here, can we increase maturity of software engineering? So the engineering qualities, yes. Of course, in the past, many things improved the maturity level. We found better high-level programming languages, structured programming, object-oriented programming, service-based, functional, logical programming. So there was a big change in programming paradigms. Unfortunately, we do not have really a hope that there will be a super paradigm coming soon that would solve everything. So expect that these are the good programming paradigms, and even if there would be another programming paradigm, possibly the lower bounds for specifying a complex systems would not change. So whatever you choose, you have a certain amount of work to do to specify things, even if you use low coding approaches or no coding approaches. They simulate less complexity, but they introduce complexity in other parts. Methodologies, the same, whatever you choose, do it well and tell people how it really works and see whether it fits to the people, because there's, again, no silver bullets. There is no super methodology around, and possibly it's because human developers are doing the work. Evolution of middleware and software frameworks, this is a very active area. We can more or less suppose that every year software middleware improves somehow. And this, of course, reduces complexity, paradigm shifts. Yes, we see, and most of you, I'm sure, are involved in that. Machine learning, AI, yeah, it's a kind of wave, and it will take a long time to sort out what it is good for, yeah. And there are many problems that can be improved by AI, and there are possibly much more problems that do not benefit from AI. But this is a kind of process that takes typically 10, 20 years to see what really works for and where AI can apply it and where AI should not be applied. AI for software engineering, yeah, that is basically a little bit the problem. The computing capabilities increase, however, we as humans, yeah, have a very steady characteristics. As Straustrup, the inventor of C++, pointed out. And one of, just a little piece, and I'm almost finished, we analyzed, and in current research, it's analyzed that all programming artifacts written by software developers shares a characteristic of so-called natural language artifacts. So there is, and yes, it's, I just want to highlight a little bit the similarity. There's not too much difference to writing a story and writing a program. It's humans write the story, they write it in a certain way, they use certain expressions, and this can be analyzed by natural language analytics, and this was done in a very famous study, 2016, which basically turned out program languages in theory are complex, flexible, and powerful, but the programs that real people, human people, actually write are almost simple and rather repetitive, and thus they have useful, predictable statistical turns out that there is no fundamental difference between what we write with a programming language and what we would write with a natural language. So we can share all insights from the natural language community as well. In my research, we are, for example, currently working on latent Dirichlet allocation schemas that allow us to find out topics in what developers do, high-level topics, some things that couldn't be found out in other ways, but AI is very useful to analyze, based on natural language processing methods, what are people working on, what do they really do, so to get a kind of abstract classification of their work. This is a joint research with Serene as well. For example, we want to find out about the know-how. It's not to assign grades to developers. It's about when you have a problem in a certain module, which developers might have the best knowledge that could help to solve the issue. Of course, you can talk to developers and they will tell you something. But what if you would use the real data of the last 2-3 years to find a good match, that is to cluster the developers with respect to one current ongoing problem, and then to select among these people. Some conclusions. Software factories are somehow different, maybe fundamentally different to the manufacturing process, but they more or less have the same problems. Yeah? Insofar as the use of factory is correct. The software complexity, is a fact and we cannot be changed. Yeah? There is no way to write simple software unless you have a simple problem. The component-based development and transparent development processes turn out to be very relevant in the future to optimize the software development from our perspective, from a science perspective. Of course, data-driven analytics, AI-based analytics might help and will help a lot to solve fuzzy issues. And that's key. Otherwise, without AI, we would not be able to solve these sometimes hardly to define issues formally. Some problems cannot be defined in a formal way, but AI can somehow provide an excellent solution because it can be trained and it can learn from and it will learn and it learns from the past. Future paradigm shifts will occur, but I think they will not have a strong impact. And insofar, software engineering is consistently increasing its maturity level, but there's still a long way to go, and maybe this event might be useful to find or to get some new ideas how to push this maturity level. Especially AI-driven approaches and information visualization approaches might help, might be one tool, one element of such a solution. And finally, talk to you about user interfaces in modern cars. I selected this picture. It's almost 50 years ago. It's the cockpit of a very well-known car. And I would like to focus on these red and blue tools you see on the right side, yeah? Okay? Here. It's obviously, everyone knows this, you can control the heating system, yeah? It's for cold and warm air, for putting the air downwards and upwards, and for steering the ventilation. Yeah? So I guess even if you take as a user a child, basically within 20, 30, 40 seconds they found out how it works, just by experience. You push these instruments and you get a feeling of how it works. And then, after 20, 30, 40 seconds, And it doesn't matter whether it's nighttime or daytime, whether you are occupied or not, whether traffic is horrible or not, you can unconsciously control the heating somehow. Okay, I found, I searched for this picture because I was so hopeless. I have a similar car 50 years ago, which offers me smart climate, classic climate, many buttons, but after 2 weeks, I'm still not able to understand how it works. And this is what is sometimes a sad experience. And for that reason, by just walking in Berlin, I found this car, yeah, and I was so emotionally affected because I thought, this is what I really want, yeah. This is what I could really use, yeah. So sometimes we also run into this problem of over-engineering. Yeah, it's a good idea to think about over-engineering and how can we find ways to detect when it starts. So this is all I would like to tell you. Yeah, thank you very much for your attention.